This will be how to do problems on page 561. We're going to go with number one to start with here. And we are trying to figure out the area of a regular polygon, and we'll round it to the nearest tenth. So I drew number one here. It says an octagon with side length 6. So I drew the picture as best I could here. And of course, with a regular polygon, the formula is 1/2 apothem times the perimeter. With a side length of 6, it should be easy to figure out the perimeter. That is, of course, 6 each side, and there are 8 sides in an octagon, so you go 6 times 8, of course, that's 48. Where the hard part is, and this is going to take all the time, is to figure out what that red line is. That, of course, is the apothem. You're going to have to start with angles. You're going to need to break down this figure into 8 triangles. So if I draw this, sorry, this is a little bit messy here, but basically 360 divided by 8, and that is 45. So each one of these guys is 45. 45 and 45 is 90 degrees. 45, 45 all the way around the octagon. And then eventually the 45 gets split. And I'm going to enlarge this one triangle here because we want to just focus in on this red apothem. We want to get this guy. The side length of 6 will get split into 3 and 3. So this here is 3. This angle of 45 gets split into 22.5. 45 divided by 2 is 22.5, and this is 67.5. And our job here is to figure out the apothem. And you're going to need trig. So you first figure out angle measurements, split up into a smaller triangle here, and then we're going to use some trig. I can stand at the 67.5, and I'll just say tangent of 67.5 is equal to opposite apothem over adjacent 3. Calculate the apothem number, plug it into this formula, and then number crunch it out, and you'll get the area of number 1, the regular octagon. Okay, let's take a look at number 18 here, the little word problem I had. It's set up in advance here. It talks about this regular hexagonal nut, and we are going to, part A, find the area of the circular hole, so basically a circle, in the hexagonal nut, and then part B, they say find the area of the hexagonal face with that hole punched out of it. So for part A, they just want the area of the hole, the circular hole. So it's basically a circle with radius of 4. So I kind of drew that already. And then, of course, area of a circle is pi r squared. So you just put a 4 there and then crunch that out for the area of the circle. The part 18b, the hexagonal face. Now they're talking about this part here in yellow. And you want to basically figure out the entire area of the hexagon and then minus out the area of the circle, which you will already get from part A. So you got to figure out the area of the hexagon first, then minus out part A, the area of the circle. As a note here, this is a 3-dimensional picture, but really this portion here, making it the 3rd dimension, we're not even dealing with that. That would be if we were dealing with volume, which we are not dealing with today. So even though it's in the picture, that 2 millimeters high is no effect on this problem. So you really need to, one, figure out the area of the circle, and then figure out the area of the hexagon. And they give you this radius of 8. You want to figure out your angles, go 360 divided by 6. This would make this 60 degrees, and then the 60 gets split into 30 degrees. And I redrew the picture here. And you're going to need to figure out, because it is a hexagon, 1/2 apothem times perimeter. So you need to figure out both the apothem, and then you need to figure out x to help figure out the perimeter. So of course you would use some sine, cosine, and tangent to set it up. And you're going to do one trig for the apothem and one trig to figure out the x. To solve for the apothem here, you got to recognize the fact that this is 8. That's the radius there, so I'll put an 8 in that picture there. You could stand at 60 degrees and then say sine of 60 is the apothem opposite over hypotenuse 8. Go to the calculator, figure out what that is. And then you also want to figure out what x is. You can again stand at 60 degrees here and say cosine of 60 is equal to adjacent x over 8. Once you have what x is, you just double it and you will get the side length. Each one of these sides, and of course there's 6 of them to make up the perimeter, put it all together, minus out the circle, and then you have the shaded region here, which is the hexagonal face.